Hello everyone, welcome back to our channel. In today's session, we will explore a very important reaction in organic chemistry. So that is the electrophilic substitution reaction. So with a focus on halogenation of benzene. So before we dive into the mechanism, let's first understand what an electrophilic substitution reaction is and what is a Lewis acid means. Okay, so before starting with the session, so let me explain what is an electrophilic substitution reaction actually. Electrophilic substitution reaction is a type of organic reaction where an electrophile replaces hydrogen atom in an aromatic compound such as benzene. Okay, so as I told you that we are going to discuss halogenation of benzene. So the main reaction, if you can observe, when benzene, it is going to react with the chlorine molecule in the presence of anhydrous AlCl3. Okay, so this anhydrous AlCl3 is nothing but it is a Lewis acid. So when it is going to react with the benzene is going to react with the chlorine in the presence of anhydrous AlCl3. So what you are going to get, my dear? So you are going to get chlorobenzene as the product and the byproduct is the HCl. So in this particular reaction, the hydrogen atom in this particular benzene is replaced with the chlorine atom here. So that is how you are going to get the chlorobenzene. Now, so as I told you, the main reaction I explained, but how this particular chlorobenzene we got, so that is what we are going to discuss. As I told you before going to the mechanism part, let me explain what is the role of this anhydrous AlCl3. So this anhydrous AlCl3 is nothing but, my dear, this is called as Lewis acid. It is called as Lewis acid. So what does this Lewis acid means? So let me explain first of all what is a Lewis acid. See here, Lewis acid, it is nothing but a Lewis acid is a substance that can accept an electron pair. Okay, so in the case of halogenation, a Lewis acid like you can take ferric chloride, ferric bromide, aluminum chloride. So these three catalysts, okay, ferric chloride, ferric bromide and aluminum chloride helps generate a stronger electrophile by interacting with the halogen molecule. So very important. See, without Lewis acid, the reaction is not going to take place because we are going to generate an electrophile. So for that, we are taking the help of a Lewis acid here. A Lewis acid, what is the role of Lewis acid? Lewis acid is a substance that can accept an electron pair. So now let us see the mechanism part of this particular reaction. See here, I am going to break down this halogenation of benzene into three key steps. What is that? The first one is generation of an electrophile. So the next one is attack of the electrophile on benzene ring, and the third one is regeneration of catalyst here. Okay, let's go through them one by one. So the first one what I have given, that is generation of an electrophile. See, in a halogenation we use a halogen molecule such as chlorine. You can take chlorine. Here the electrophile can be see here, if you are doing chlorination, you can take the help of chlorine molecule. If you are doing bromination, you can take the help of fluorine molecule. If it is chlorination, if it is chlorine molecule you are reacting, it is called as chlorination. If it is bromine molecule you are using, we call it as the bromination. Now here, let us see the reaction part here, the mechanism part. See here, first step here. So as I told you, it is a chlorine, generation of electrophile. So let me take here the first one, chlorine molecule. I am writing here chlorine molecule. So here what happens, initially first the here heterolysis, between the chlorine atoms there is a bond is present. Between the bond, a single bond is having one pair electron. So this one of the pair of electron, it will be accepted by the one of the chlorine atom, so that So what you are going to get, my dear, so one chlorine atom, it is going, see, when we are reacted with the aluminum chloride, that is anhydrous aluminum chloride, so what will happen, this Lewis acid, it will accept the pair of electron as I told you. Then what is going to happen, my dear? So this AlCl3 becomes AlCl4 minus, and whereas this particular Cl atom will have positively charged. So this is our target site, that is what we are calling it as an electrophile here. Okay, so our electrophile is generated. The next step, what I said here, the next step here, the attack of electrophile on benzene ring. Now the Cl plus electrophile attacks the benzene ring. So how it is going to be, let us see here. So let me take here benzene, I am writing here benzene ring, which has got pi electron, 3 pi bonds are present. So it is rich with the pi electrons which are loosely held in the benzene. Now we are going to attack the Cl plus as electrophile. So this is electrophile. So now it has to attack on the benzene ring. How it is going to be? So we don't have any, to attack, at least one pair of electrons are required. So how the Cl plus is going to attack here? Electrophile is going to attack on benzene ring. Now see here, this particular pi bonded electrons, first initially it is going to shift here. So then it will have a negative charge here. So the next, what is going to happen with this a pair of electron, this particular Cl plus, it is go and form a bond with the benzene ring. So next, what will happen here? So I'm going to write the product it as initially. So I'm writing here already one hydrogen atom is present to E, and one Cl is being attacked here. So the other 2 pi bonds I'm writing as it is here. Okay, so when these particular pi bonded electrons are shifted here, so what will happen? This particular carbon will have positive charge here, but even though this particular compound is again unstable, now next what will happen? This particular compound will undergo resonating structure here. So it will undergo resonance. So what will happen here? So again this particular pi bonded electrons will be shifted here, so that again one more resonating structure is going to possible, so that I am writing in this way, hydrogen chlorine. Again these particular pi bonded electrons are shifted here, so it means here you will get a positive charge here. Again this is also unstable. The next, these pi bonded electron will be shifted here. The next I am going to get the one more resonating structure, so I am writing here pi bonded electrons, hydrogen, and here Cl. Again where I am going to get the positive charge, I am going to get the positive charge here. Again this is unstable, so what will happen here? This particular hydrogen atom and carbon hydrogen bond, so it is going to enter here. So the next structure, resonating structure, what you are going to get here, the hydrogen is being replaced, this particular hydrogen is being replaced, it has H plus. So the next possible structure you are going to get it as, so like this, with a chlorine attached. So what is being replaced, my dear? Here proton is being lost here. Okay, so whatever the proton it is losing, okay, so initially we have taken AlCl3 as the catalyst, but it has converted into AlCl4 minus. So in the third step, we are going to regenerate that particular catalyst, that is AlCl3. How it is going to be? See here, whatever I got it AlCl4 minus, AlCl4 minus in the first step, it is going to react with the proton of second step, whatever we got it here. The next what will happen, I think you understood, my dear. See here, so here it will be converted into AlCl3, and H plus will combine with the one of the Cl minus, so it is going to form HCl here. So this is our regenerated catalyst. Okay, so this is how the mechanism of halogenation of benzene ring. Okay, so I think the concept is clear for you. If you found this video helpful, don't forget to like, share and subscribe to our channel. For more chemistry content, comment below if you have any questions. See you in the next video. Thank you.